Welcome friends, we are discussing two-port networks. Now in this part we shall discuss the symmetrical network. What is a symmetrical network? Let us first understand. Suppose we have a network. We have an input voltage V1 and current I1, and at the output port we have a voltage and current I2. Now the symmetrical means with respect to this network both sides look symmetric, both sides look same, which means if you calculate this ratio V1 by I1 and if you calculate this ratio V2 by I2, they must match in terms of if that network is symmetrical, then if you imagine this is a mirror, what is a symmetry? That means with respect to that mirror, that means you see, if it is a mirror, then A is a symmetrical letter. A is a symmetrical letter. So with respect to the mirror, A is symmetric in every respect. So with respect to that network, input side and output side looks exactly same. So if you calculate this ratio V1 by I1 and if you calculate this ratio V2 by I2, so irrespective of the the port, input port or output port, the ratio of voltage and current becomes same. So that is the condition for symmetrical network. So now let us quickly solve what is the symmetrical network, or rather what are the how in how many ways we can prove that a network to be a symmetrical or not. So similarly we can solve it, or we can prove it by 4 different ways in terms of each parameter. Now unlike this way, previous case, now this time we have to open circuit the respective terminals. So let us say we have a network. This is V1 and I1. Now output port, now this time we need to take open circuit. So as you open circuiting it, then the respective current becomes 0 and it will have a voltage V2. So let us do that in terms of Z parameter. Again, these are the two fundamental equations. When I2 becomes 0, then V1 is equal to Z11 I1 and V2 is equal to Z21 I1. So V1 by I1 is immediately follows V1 by I1 is equal to Z11. And if you carry this similar analysis, suppose we have a network and now this time you are exciting it from the output port V2, which is injecting some current I2. Now you are making open circuit the input terminal, so it will have a output voltage V1, I1 should be 0. So when you make V1 is equal to 0, then you will get from the second equation V2 by I2, that will be equal to Z22. So as per the definition, V1 by I1 should be equal to V2 by I2. So that immediately we can draw the conclusion from this expression. If we found a network, or if we found in case of solving any problem Z11 is equal to Z22, then you can say that network is a symmetrical network. Now let us moving on for the Y parameters. So these are the two fundamental equations of Y parameters. I1 is equal to Y11 V1 plus Y12 V2 and I2 is equal to Y21 V1 plus Y22 V2. So we have that network, same network, let us say any network. We are exciting it from primary side V1, which is inject some current I1. Now let us make open circuit the output data, output port, right? It is V2. So I2 becomes now 0. So when I2 becomes 0, so from equation from 2b, from equation 2b, we can write when I2 becomes 0, then V2 equals to minus Y21 by Y22 V1. It from 2b you can write. So now if you substitute V2 in equation 2a, so we will get I1 is equal to Y11 V1 plus Y12. Now you are substituting V2 is equal to this. So if you solve, you will get Y11 Y22 minus Y12 Y21. We say this one as delta Y divided by Y22 into V1. So if you take the ratio V1 by I1, you will get this Y22 divided by Y11 Y22 minus Y12 Y21. So that is the first condition. V1 by I1 is equal to this. And by doing the similar process other way, this is the same network. Now you are exciting it from the output port and you are making open circuiting input port that leaves a voltage V1. So you will get a similar relation. V2 by I2 will be Y11 is equal by delta Y. So that follows, immediately that follows, according to the condition or definition of symmetrical network, V1 by I1 should be is equal to V2 by I2. So that immediately follows Y11 is equal to Y22. Now let us continue our discussion on ABCD parameter. We have this ABCD parameter fundamental equation V1 is equal to AV2 plus BI2, I1 is equal to CV2 plus DI2. So we have that network. So let us have V1 as my input voltage and I1 is the input current. And let us make output port open circuited, leaving behind a voltage V2, which is open circuit voltage. Now I2 0, open circuit means I2 becomes 0. So I2 0 means from, from both the equation 3a and 3b, this I2 0 means these two will go away. So V1 by I1 immediately comes A by C. V1 by I1 it immediately comes A by C. And by maintaining similar process, if you have done the same thing, we have the same network. Now you are exciting it from the output port and we are making open circuit input terminal, leaving behind the open circuit voltage V1. So when V1 is equal to 0, then V2 by I2 should be minus D by C. It is from 3a. So as per the definition, you see A by C is equal to minus D by C. So this is the condition. The magnitude of A and magnitude of D must be same. Magnitude of A and magnitude of D must be same. Lastly, we have H parameters. Let us say we have the definition V1 is equal to H11 I1 plus H12 V2. I2 is equal to H21 I1 plus H22 V2. So by making I1 is equal to 0, by applying similar process, by making I1 is equal to 0, V2 by I2, V2 by I2 is will be 1 by H22 from equation 4b. From equation B, because if you making I1 is equal to 0, so this will go away. So from this V2 by I2 you can say 1 by H22. Now by maintaining similar process, if you make I2 is equal to 0, so you will get V2 is equal to minus H21 by H22 I1 Now if you substitute this V2 value in equation 4a, so you can get V1 is equal to H11 I1 plus H12. Now in place of V2 you will substitute minus H21 by H22 into I1. So if you solve, you will get V1 by I1 is equal to H11 H22 minus H12 H21 divided by H22. So if you compare V1 by I1 and V2 by I2, if you equate these two sides, then we get H11 H22 minus H12 H21, that must be equal to 1. So this is the condition. So similarly, so when you have a network, any network, that network can be reciprocal or can be symmetrical or neither reciprocal nor symmetrical. Now whether a network is a reciprocal or not, it can be proved by 4 different ways. These are the ways. Okay, if you get these results, you can say that that particular network should be a reciprocal network, right? On the other hand, solving, if you find these conditions, Z11 is equal to Z22, Y11 is equal to Y22, A is equal to D, and delta H is equal to 1, you say, you can conclude that that network is a symmetrical network, right? So any network can be reciprocal provided these conditions, can be symmetrical provided these conditions, can be a network, any single network can be of both, reciprocal, symmetrical, both, or maybe neither of them. That means if you encounter a network, it is not necessary that it must be a reciprocal network or a symmetrical network. It can be even both reciprocal as well as symmetrical network, or neither of them, in neither a reciprocal network nor a symmetrical network, depending on these conditions, right? So with this, I am ending this part. So from the next session, we shall solve numerical problems. Thank you.